In this video, we are going to see how to form and use doubly augmented matrix to find the inverse of a matrix. Actually, the idea is pretty simple. We will have an augmented matrix of the form AI, meaning A being the coefficient matrix and I being the identity matrix. Then with row operations we will get the matrix I A to the minus 1 or A inverse, as I being again the identity matrix and A to the minus 1 or A inverse being the inverse of A. Now let's see how this works. But before, please notice that the identity matrix changes its place. And once we start with this form after row operations, we try to get the identity matrix instead of A, so that once we get the identity matrix, whatever we get on the other side becomes the inverse matrix of A. Let's see how. Okay, in this example we'll try to find the inverse of A if it exists. Now first we start writing the doubly augmented matrix, which is this. Now we will try to get the inverse matrix here, and whatever we get here in this part will be our inverse matrix. Let's start the row operations. Now first of all we should have the leading one, so I will divide the first row by 8. So you see, whatever I do to the left hand side, I do to the right hand side to the identity matrix. Next, I'm going to multiply the first row by 3 and add to the second row. So it will be like 3 minus 15 over 8, 3 over 8, and 0. So let's add. So it will be 3 minus 3, 0, and minus 15 over 8 plus 2, which is 16 over 8, is 1 over 8. And on the right hand side, 3 over 8 plus 0 is 3 over 8, and 0 plus 1 is 1. Now, if I multiply the second row by 8, I will get 1 in that row on the left hand side here. So I will do that. So here the second row will be 0, 1, 3, and 8. Now if I multiply the second row by 5 over 8, it will be 5 over 8 here, so 15 over 8 here, and 40 over 8 here, meaning 5. So adding the second row to the first row will give me 1, 0, and here 15 plus 1, 16 over 8, so it is 2, and 5 plus 0 is 5. On the other hand, downstairs is 0, 1, 3, 8. Now you see I have the form of identity matrix and another matrix, which I call it the inverse of A. So according to the method, this should be the inverse matrix for A. Now let's check this out. So if I multiply the matrix A with its inverse, or if I multiply the inverse of A with itself, then, or A, we will be getting the identity matrix. Let's see if it works. So multiplying these two matrices will give me 8 times 2 will be 16, plus 5 times, minus 5 times 3 will be minus 15, and then 8 times 5 will be 40, and minus 5 times 8 will be 40, so it will be minus 40 here, and we'll have minus 3 times 2, which is minus 6, plus 2 times 3 is 6. And here as a last entry, minus 3 times 5 is minus 15. And 2 times 8 is 16. So if you do the additions and subtractions, we will get 1, 0, 0, 1. So if you do this second multiplication, which is A inverse times A, you will see that you will get the identity matrix again. So whatever we find here, A to the minus 1 or A inverse, is true. Now please try to use the method yourself. Please try to find the inverse of these matrices if possible. If you cannot find the identity matrix on the left hand side as in this form, if you fail to get the identity matrix here and there is no other way to get it there, then this means the inverse of the matrix does not exist, so it is a singular matrix.